I think a lot of people get focused on ML, AI, but there are subtle things about what we're doing that are a little bit different, but there are a lot of things that are just about modern distributed computing and how software works on like medium-sized collections of computers. And a lot of people work on software on medium-sized collections of computers. So I think the thing I would say is, for people who are going into ML and going into data sciences, if you're excited about the model building and you're excited about like that side of it, you should go to that. But there's going to be a huge amount of work for a very long time in making this stuff work. And so if you are a software engineer, you are a systems engineer, you are a data like management engineer, and you are an SRE, like this is really, really good stuff to know. And you should not be worried about not having the academic background in modeling.
Welcome to the Software Misadventures podcast, where we sit down with software and DevOps experts to hear their stories from the trenches about how software breaks in production. We are your hosts, Ronak, Austin, and Guang. We've seen firsthand how stressful it is when something breaks in production, but it's the best opportunity to learn about a system more deeply. When most of us started in this field, we didn't really know what to expect, and wish there were more resources on how veteran engineers overcame the daunting task of debugging complex systems. In these conversations, we discuss the principles and practical tips to build resilient software, as well as advice to grow as technical leaders.
Hello everyone, this is Guang. Our guest for this episode is Todd Underwood. Todd is the Senior Director of Engineering at Google, where he leads site reliability engineering teams for machine learning. Having worked on SRE at Google for more than 12 years, Todd recently gave a talk on how ML breaks in production, drawing on more than a decade of outage reports and postmortems. In this conversation, we go into different aspects of what makes it difficult to do ML well in production, like why it's not enough just to look at aggregated statistics for ML monitoring, and who is on the hook when ML models don't perform as expected in production. We also chat about what Todd looks for when hiring ML SREs, his impressive skill of getting LinkedIn skills endorsements, and much more. Please enjoy this insightful conversation with Todd Underwood. Awesome. Hey, Todd. It's great to have you with us today. Welcome to the show.
Great. Thanks for having me. I'm excited to have the conversation.
So when we were LinkedIn stalking you to prepare for this episode, I saw that in addition to leading reliability engineering efforts for ML at Google, you're also the Pittsburgh site lead. I've never heard the title of site lead before and thought that was really cool. Can you tell us more? Like, what does the role of a site lead entail?
Yeah, absolutely. But I do want to start with a digression, which is I am disappointed that what you didn't focus in on my LinkedIn page was my skills. So as I'm sure those of you who work at LinkedIn know, most of us in the real industry think the skills thing is silly and not useful. So my particular brand of personal protest against the skills is to have outrageous and ridiculous skills. Among my skills are nuclear proliferation, brunch, locomotion, and pork. And I should clarify, I'm a vegetarian, so the pork skill is more about detecting and avoiding pork than enjoying it. So I just want to say, like, there's good LinkedIn skills out there, and you should all be seeking out these skills. There really are. So sorry for that.
Polluting the data for training models.
I am helping. How many people are good at brunch? Brunch. I have skill in something called, so there's a CAD/CAM package called rhinoceros, but rhinoceros is also just a common noun for an animal in English, right? So I have a skill of rhinoceros, and so it's just an animal, like it's a skill.
I don't know, Todd. Some poor ML SRE, late at night, it's like, why is this model giving really weird results?
I want to point out one of my top LinkedIn skills, which is a self-documenting skill, is the skill of getting LinkedIn skills endorsements. That is one of my top endorsed skills, which is true because I'm really good at getting LinkedIn skills endorsements.
I'm really curious about what kind of job recommendations you get, Todd.
So one time, I think it was some kids from Blizzard, it was some video game company, were like, we know you're not going to move here. You said you weren't going to move, but we just wanted to reach out and say we really enjoyed your skills, and we've been having a tough day looking for candidates, and you like your profile really brightened our afternoon. I'm like, that's a thing. Brighten some recruiter, some sorcerer's afternoon, right?
Well, if not,
sorry, let's go back.
Good for culture fit.
That's what I'm like. Yeah. So Good. So a site lead. So one of the things, different companies work differently. Google has a huge engineering organization. And one of the things that happens is, like, when you think about engineering organizations, they're mostly organized functionally or by product, right? You work on a thing, whatever that thing is, whether it's like some kind of engineering and some kind of engineering organization or some kind of product and some kind of product organization. But that's your day job. But this is inconvenient for those of us who work in technology. Humans exist in a place and time, right? Humans are not sort of little abstract bundles of possibility that like just exist on some theoretical plane. They live in cities. They have houses. They have like families. They walk and they bike and they eat food and they have labor conditions and they have salaries and they pay taxes. There's all this inconvenient stuff about us all being humans. And also like, I think one of the things that I am always disappointed about our industry, the technology industry, is it spends a lot of time pretending that we will all just move anywhere at the drop of the hat for any particular reason. And that's absolutely true for some people at some times. But actually, a lot of people have families, they have communities, they have places that they prefer to live and places that they don't. Like, people don't like living at a place they don't feel comfortable in. They don't like living in a place they don't feel welcome in or they don't have good ties to. And so a lot of companies try to pretend this isn't true and anybody, like all of the top talent, will just move anywhere. But it's just not true. Like, we live in a place. And so the job of a site lead is really to oversee, curate, and set up the conditions for success of all of the different organizations that employ people in a place. So in Pittsburgh, we've got about 1,000 people working for Google, roughly in that area. I think it's a little bit somewhere in that area. And so like, there's a building and there's recruitment and there are, benefits issues and there are, especially in the last year, there's health and safety issues, right? Like, our office is closed and like, when's it going to reopen? And so that's an example of a question. Like, you can't have like the ads lead and the cloud lead decide when the Pittsburgh office reopens, because that, from their perspective, that's a weird edge case. From our perspective, it's our entire life, right? Like, this is where we live and work. So that's really what a site lead does, is set up the conditions for success at a site.
I see. How did you get put into that? Or like, is that something that you...
I mean, mistakes were made. Clearly, like, everybody else stepped back and I wasn't, and then I ended up using... I mean, I think like, it really is like at, different, it sounds super fancy or it sounds important, but it's really like who failed to avoid doing it. When I was being asked to do it, someone told me like, don't do it. Under no conditions do it. It's not the kind of work that's rewarded. I'm like, okay, cool. And then, so I, you all may as well, like, I interview a lot of people. And so one of the things when you interview someone is you try to form an opinion, positive, negative, good at this, bad at this, but then you look for evidence that you're wrong because you want to test, like, maybe I was jumping to a positive or a negative conclusion. And so just really quick, I said, okay, cool. I got it. I shouldn't do it. Just out of curiosity, if I were to do it, what's the reason I would do it? And they're like, oh, you would do it if you really cared about that stuff, if you were positive nobody else was going to do it, or you didn't think the people who were willing to do it were going to do a good job of it. I was like, well, that's disappointing because you just talked me into it. Like, you had talked me out of it. And then yeah. But it's weird. It's a really important job, but it's not an engineering job. It's fundamentally a job about setting up the conditions for human success.
I see. Very cool. So when you first joined Google as the SRE manager, you working on online applications like ads, payments, and now you're leading the ML SRE team. Like, what made you decide to switch, and what was that transition like?
Yeah, it was really an outgrowth of it. So I started the ads ML team in Pittsburgh. There were sort of 2 engineers with no manager when I started, and I built that team and built SRE in Pittsburgh up from those 2 people to about 150 people that it is now. I mean, Google employs a lot of people, so that's still a small site, but it's like, it's enough. I think our objective was people should have choice. Like, engineers like to work on different stuff. Like, each of you, like when we were chatting before the show, like, you're just like, I used to work on this, but now I work on, because that's what we like to do. People need like good, like, options. Not always because they're doing a bad job. Sometimes you're doing a great job, but you're just bored. You're like, I did that. I want something new. I want a different challenge and to try to apply my skills. So the first team that I joined was this team working on productionizing ads machine learning infrastructure at Google. And as you all may know, and I think a lot has been written about, like Google's been using machine learning to target ads for a very, very long time. It was even controversial in the early days. Like there was this funny news story where, I'm trying to remember how it went, but as I recall, sort of Yahoo was like in the market and they were trying to make this new ad serving system as sort of one of their last gasps of trying to figure out how to like pivot from the portal version of like the closed walled garden version of the internet that they'd been doing very well with, the sports at Yahoo and the finance at Yahoo was great, but like the search, they just couldn't really nail, and they couldn't nail the advertising part of it. And at one point, someone from Yahoo said, well, Google's doing well here because they use math. And we're like, so then there were some t-shirts made that said Google ads quality, we use math. Because like we just use math. Like it's public math. It's not secret math. Anyone could use the same math. So we productionized that stuff. And then, I think I did some work on payment systems and I did some work on a few other systems, but I always like noticed that those ad systems were highly tuned for that application, but other places that I looked in the company were not as well served with general purpose infrastructure for their machine learning use cases. And I think, as the revolution in deep learning happened in the sort of 12 to 15 period, and people were starting to see like, hey, this is actually usable for a really wide variety of use cases, natural language use cases, image use cases, fraud and abuse use cases, all kinds of other prediction use cases. But the underlying software infrastructure is still bespoke, complicated, finicky. And so when you look at an application, like something simple, like when you, in Gmail or in Android, when you have type ahead, where you, like on a phone, that's genius. That's like predictive typing is amazing, right? Because like these input, like in spite of how like the kids these days and their fast thumbs, like these are not great devices for inputting significant amounts of text. And so if you can tell me not just like, predict this word, but the next 6 words I'm about to say, because you know me or you know how people speak this language that I'm speaking, that's amazing. Well, there's a model that needs to do that. Like and then you have to sort of do this calculation. Like, is that a small idea or a big idea? I think that's a small but good idea. Like, I don't think it's a big idea. So if I were running a company, I would not assign a team of people just to do that one thing. Like, that looks ridiculous. That looks like a waste of time. But if your infrastructure is sufficiently complicated, you probably need several people working on that just to ship that one feature. And that's not cool, right? And so I think that was that kind of thinking of, we're generalizing this infrastructure. At the same time, Google was in secret shipping TPUs that we've now announced publicly, but these amazing hardware devices that really cost effectively do basically low precision linear algebra. And so we're looking at these things saying, hey, there's a revolution here, but the reliability and the simplicity is not facing the developers yet. And so that's where I really got interested in. So I founded the ML SRE team and I've been building it up ever since.
Dang, that's really cool. I guess changing gears a little bit, like Google being a pretty global company with, offices all around, probably means, a lot of your teams do work in the kind of distributed manners even before COVID. Are there like practices that you found that really helps, keep good communications across channels, across these different teams?
Yeah, for sure. I think like one of the benefits when you talk to people, and you all may experience it as well at your organizations and in your history, when you talk to people who do this kind of distributed work, the most successful thing is not having one place. It's having like everything being somewhere other than the main place. There was a neat trick. There was a good example. I think it was Vijay Gill when he was at Google, but there was an example of like, there was a big meeting at the home office in Mountain View for some networking thing. And then there were several people at some other sites. So maybe in Sydney or maybe in Dublin or maybe in New York. Okay. So that's fine. He broke up the big meeting into 2 meetings. He just booked 2 smaller rooms instead of 1 big room. And so it wasn't that like you didn't have to go to either room, but you couldn't fit everyone in 1 room. And so all of a sudden the meeting shifted from in the room with some like remote participants to on the video conference. And so I think things like that are like genius things to do. For the COVID front, Google had a culture of video conferencing for a very long time. Like, when I went to Google in 2009, they'd already been conducting 100% of their interoffice meetings on video on these old Tandberg devices for several years, like since 2006 or 7 or something. And so like we already had like every conference room had video capabilities. Sometimes they were like little goofy devices with small screens, and sometimes they were a little bit bigger. But by the time last year rolled around, like that was just how all meetings happened. So that's fine. But what we found is that we were still relying really heavily on periodic in-person contact. And like, I think all of us have found like working from home, like I like working from home, but I don't like only working from home. I don't like always working from home. I've got a solid, quarter or third of my coworkers that I work closely with who I've never met. And I think there's really good evidence that as humans, we form trust affiliations and we have high bandwidth communication because of in-person interaction. Now, as a nerd, I think that's super disappointing. I'm like, I see people on the screen. It's fine, right? But for some reason, it's not completely fine. And so I think the jury's still out on what the right thing to do there is. The New York Times magazine last summer, which was early in this, like, I don't know, we felt like it was the middle of it, but it was not. But it was like in June or something, had this whole episode on working from home technologies. And there's a ton of good research in that episode that have all kinds of things. I guess they call them editions if they're newspaper, not episode. Apologies. There's a ton of good science in there. And some of the science is things like staring at your own face is tiring and weird. So like this default that most of our video interfaces center us, that's weird because you're not used to looking at yourself and it makes you self-conscious and annoyed. Staring at other people 100% of the time is also weird because if you think about if you're in a meeting with 6 people, you're really only looking at 1 or 2 of them at any given point in time because 2 of them are sitting next to you and you can't look at them unless you like turn around and look at them, right? But now we're like, you're in a meeting with 12 people and you're looking at all 12 of them all the time and your brain is exhausted because your brain is trying constantly, it's scanning to parse all of that state, all of that emotional reaction and facial reaction. And so I think there's a bunch of stuff. I'm both excited about the fact that we've moved a lot of interaction online, but disappointed in how little we've innovated so far. Like we need to experiment a lot more before we get this really right.
Yeah, I can definitely relate. My brain is definitely doing all that processing on all the faces, definitely not browsing Reddit or, anything like that. So absolutely.
No. Hacker News, never. Twitter, not at all. No.
Cool. So at the director level, I know that you're on a lot of hiring committees for ML SRE. And I imagine that, finding people that are both experts in ML as well as infrastructure engineering is really difficult because I think the backgrounds are almost kind of orthogonal. One's like a little bit more academic. The other one is more hands-on practical. In another interview, you mentioned that actually most people working on reliability engineering for ML at Google don't actually have an ML background. So I thought that was really surprising, but also makes sense. Like, tell us more about that. Like, how have you grown your teams? Like, what do you look for in candidates? Love to learn more.
Yeah, for sure. I think more broadly for SRE, I think there's probably an analogy between software algorithmic skill and SRE and ML skill and ML SRE. And let me explain what I mean by that. I think when I look for, I've been hiring SREs at Google now for 12 plus years. And when I think about can I teach someone the right attitude and approach to SRE or can I teach them software skills? You're like, well, you can teach either side of that, but you really have to address that gap somewhere. So if I get someone who's pure software oriented and has never really thought of from a systems perspective, that's a pretty steep barrier to overcome. Likewise, if I get someone who's like really thinks from a systems perspective and has no software sense at all, like that is also from an SRE perspective, a pretty steep barrier. I think that's analogous to the ML front. What we see in the ML front is much of the work that we do on ML SRE requires very little deep understanding of machine learning, very little. Now, that fades pretty quickly because what it does require is understanding how these pipelines fail, what the requirements of them are, how the structure of the systems fit together. I'll give like two concrete examples. One is the difference between, say, reinforcement learning and, something like supervised learning. So in a supervised learning situation, you have, a bunch of examples and you're trying to apply labels to those examples. And you're using that to produce a set of, lookups or predictions where you can categorize novel events, right? Or novel examples. That has a flavor to it, right? That has actually a kind of linear left to right pipeline to it. Now, if I talk about reinforcement learning or something that has unsupervised learning followed by supervised learning, followed by a human agent going back to the supervised learning, now we're like, oh, from a systems perspective, you don't even need to know what those words mean. But I just strung the boxes together in a pretty different pattern, right? And if you understand a little bit about what that means, you'll understand a lot about how it's going to break. And so I think one of the things that, people who start on ML SRE who really want to be working on machine learning algorithms and modeling are super disappointed because we don't do a lot of that. In fact, we do very little of that. And so that's actually a bad fit. Like having a ton of ML expertise and really wanting to work on building models, that's not what we do. Google has lots of teams that do that. They really have some of the best model builders in the world. And so if you can't get hired by those teams, that is not my fault. That's like, those folks have to figure that out. But on my teams, it's cool if you know what a model is. It's a set of like pre-distilled computation. It's cool if you understand that these data processing pipelines are hyper data sensitive in a way that traditional, data processing pipelines are not. Like they're sensitive to small changes in distribution of the data. They're sensitive in small dropouts of particular parts of the data. That's novel and interesting. And as an SRE, I hear that as like, oh, new failure modes, new really, really subtle failure modes. That's great. That's cool. That's where I live. That's what I want to understand. But you don't need to know like very, very detailed, substantive model, like 99% of what happens at NeurIPS is not relevant to what we do this year, although it will be in 5 years.
One thing that you mentioned before is sort of like having that empathy because you do have the context of like, how these models work. So like, where they could potentially break. Does that come into the picture a lot? Like when the SREs work with like the model builders or work with the devs, do you see that like kind of a big piece or is it, middle of the road?
No, so I think in technology, one of the biggest problems all of us have is that we frequently don't treat each other like human beings, and I'm disappointed by that. Like I just say it that way. Like I think like it is easy, and this is worse. This is worse in the last year because we are all stressed out. We are all tremendously isolated from each other. We're missing our families. We're missing our friends, and we're angry. And we frequently take that anger out on the people on the video conference near us. I'm going to yell at you all in a second. I'm just going to start yelling. But so I understand that. But in reality, like everyone who's participating in these really big, complex bits of infrastructure is just trying to do their job. They're trying to innovate. They're trying to, and in particular, the ML stuff, they're trying to solve an interesting problem that's worth solving. They're trying to do something that's good for users often. Like people give ads a bad name, but like ads is what makes the internet free right now. And that's cool. And ads should be good. Like if I want crappy ads or good ads? I want the good. I mean, we'd all rather have no ads, but if there's no ads, all of the stuff costs money. And honestly, each and every one of us has chosen not to pay for that. Like we keep doing it. Like you may not admit it to yourself, but you've done it. I've done it. Right. And so we're like, well, if I'm going to have ads, I want ads that are stuff I care about, stuff I might care about. I'll click on them if they're very, very, very good, maybe, right? We all think that. But so like even the people just doing stuff that we think mundane and boring, but people trying to stop fraud, they're not trying to let people's lives inconvenient. They're trying to make a payment system work and be affordable and be fast and be functional and have people not steal our money and not steal your money. So yeah, I think empathy is a huge part of it.
Cool. And sort of speaking of, things not working, so you gave this talk recently about how ML systems break. What really caught my eye during your talk there was this slide where you had 19 different categories of failures, in terms of thinking about how things break, and that's sort of being kind of aggregated from years of experience, like looking at postmortems of, how things fail. So, this sounded like a really good opportunity for playing bingo. So did you guys play this during a quarterly ML SRE offsite, or is
that's a really good idea. See, now that you say that, the honest answer is no, not yet. Now you say that, I'm like, this sounds really good.
Can you send me a copy when you guys do,
I know, I'll send you a copy of the bingo card. That's a stellar idea. Most of the work for that talk was done by Daniel Papazian, who's a stellar engineer that I've worked with for years. And so we got to, all of us who have worked on this stuff for a long time have this sense, it's not the ML that breaks, it's everything else. And sometimes the breakage is related to the ML. So I'll give a good example. If 10% of the data goes away, but it's a biased 10% of the data. A good example would be if we train a model that has language, what language the model comes in, and we drop all of the stuff that's in Spanish. Well, we're going to have really weird results for anything that is about or in Spanish as soon as we finish training that model. But if that's only 8 or 9 or 10% of our total data, as an SRE working on that, you're there's a little bit less data today than there was yesterday. I might not notice, right? And that's the problem, is you can lose these little slices. What if the US lost all of the data from Georgia and Alabama, but not Louisiana or, Mississippi? You'd have weird results about certain regional things in the US South that you wouldn't have otherwise. And so I think, but in general, most of the things that go wrong are the format was wrong, so I stopped being able to parse the file. That's not an ML thing. That's happened to every single person who's ever worked with a computer. I set up a template to read from the file changed, or my template changed, and now they don't match, and now I'm not reading from the file, and I didn't notice really quickly, and so now I'm not loading any data, so now I'm behind because I got stuck on this thing that I wasn't supposed to do because I should have been monitoring it and not screwed it up. Right? So that's fine. So we saw a lot of that, and I think when we looked at it, we really did find that systems thinking and general SRE work is by far the most important thing on working with ML systems. Now, you're always going to have some people who know quite a bit more about how machine learning works, but the general systems monitoring thinking is the most important part.
That's really well put. I liked how you brought up just the whole aspect of folks going into ML ops, maybe sometimes think they're going to do a bunch of machine learning and then end up not. This helped explain a lot of it. But another thing I was actually really curious about was, how do new folks that enter in the kind of the ML ops, are they embedded with specific product teams, or is it more on the platform side of we are responsible more for making sure the workflow of how these teams train new models and how they stitch them all together? Are they more responsible for more on the platform side, or is it even some that are I'm going to be working on, I'm an SRE that's very closely tied to the ad section and work with them very closely?
Yeah, I think it varies. I think we would like to be more on the platform side, but to do that, you have to have mature enough and widely adopted enough platforms. And so one of the things I think, I'll just be frank, a lot of people are oh, Google solved all the problems. We have not solved all the problems. And so here, among the problems we have not solved, we don't have a super reliable, super general, widely adopted single set of ML platform technologies used by everyone. I wish we did. We have pieces of that, but we don't have that, right? And I think a lot of companies are oh, Google's got to have that. We should build that. I'm you should build that, but we also should build that. And we're working on it. You should too, right? And so when I look at my SRE teams, one of the things I see is sometimes you will see people working on a platform. I'll give you an example. We do have basically a TensorFlow serving system. You give us a TensorFlow save model, and we'll just distribute it around the world and answer questions about it. Now, you all know, That's not a very complicated service. I mean, when you do it at a very large scale, it's more complicated, but like you get the idea. You give me a model, I'll answer questions about it. That's the whole thing. The whole idea I just said in like 2 sentences, very short sentences. Well, that service is very successful because the value proposition is there. It's easy to understand how to build that service. It's moderately easy to scale that service. Lots of questions about SLOs, lots of questions about like latency, lots of questions about manageability, blah, blah, blah. Like, but you would get that in any very, very large service. When you start backing into stuff like, well, build me a training system. You're like, cool. What do you mean by training? What counts as training for you? You're like, and some people say like, just supervised learning. Like I just give you the examples and you build the model and it looks like here's the config for the model, do these instructions and then put the results over there. Okay, that's one thing. Somebody else will say, take the examples, do unsupervised learning to create clusters, send them to some human eval agents to label samples of a subsample set of this class. We can't do the whole thing because that would be very expensive and tedious. Then take those examples and run some supervised learning, then subsample that back out to go see how well you did, then run it through and you're like, okay, that's a different thing. And that's also training, right? And so what we find right now is for the simplest cases, we have platforms and we have people coming in and working on those platforms. For the more sophisticated cases, we have more bespoke assembled bits of infrastructure, and those bits of infrastructure are worked on directly by a single SRE team. So the best example of that is probably CCAI, the contact center AI application that Google Cloud AI sells. Like, I'll be honest, I thought this thing sounded boring. I thought this thing was not going to fly, right? This is, you all are nerds. You'll get this. It automates call centers. Like, okay. Why is that a big deal? Like, who calls people on phones? Turns out everybody.
Thing to say.
Oh my God, people call people on phones. So it turns out a lot of people call a lot of businesses on phones, and it's very expensive. And a lot of this is subject to different kinds of automation. So some of the automation is understanding the customers and like understanding what their questions are and routing them to agents. Some of the automation is listening to an interaction between an agent and a customer and populating documents and populating resources on the agent screen before the agent types. Some of it is chatbots. So all of this is really bespoke, complicated speech to text, text to speech, chatbot technology, serving technology, this custom interfaces to telephony for each of the providers. And so, no, we don't have a platform that does all that. That's a team that builds that bespoke stuff and then works. And so the SRE team works directly with that team on that application.
Interesting. And do you, but kind of rewinding back, like, would your vision, for both Google and for the broader sort of MLOps industry is to have this more universal platform that basically would enable, different use cases by devs to create new things. Would that be fair to say?
I think so. Yeah. But let me put and as people who work sort of are aware of this space, you might, this might resonate with you. I think we're at a tough spot because so cast your minds back 5 or 6 years and think about what machine learning infrastructure looked like and what were the models people were building and what were they trying to accomplish with those models, and think about today, right? So, and now think about 5 years from now. And so what I don't want to do is pour like service and code concrete over what we're doing right now and say, this is all you can do. You can't do anything else. Because I really do think there's quite a lot of innovation left. In fact, I don't think we're even close to knowing for sure all the stuff we want to do. So that's one side of things. But the other side of things is, but by being hard, we're actually making it really, really difficult for smaller teams who do have simple use cases to just innovate, to just do something and get anything out the door. So I think what I'm in favor of is a couple of things. One is building reliable, simple platforms for the use cases we're positive a large number of people have, because I think that just enables them to get their work done, enables them to like the phrase innovation has a bad, like that word has a bad vibe to it because we've all been sort of like lied to about innovation. It's been used stupidly, but like I really mean like creating new ideas, trying new ideas, solving problems in a new way. I think there's a lot of that in most of our organizations that's tied up because people are like, oh, I had an idea for an ML model, but then like, I couldn't do it. So I just moved on to my next idea. And you're like, well, why didn't we want to try your idea? Like, to be frank, your idea was probably dumb because most of our ideas are. No, and I'm honest, but like part of what lowering the cost to try it out does is make it faster to find the good ideas by making it faster to work through the bad idea. We all have bad ideas. I want 10 bad ideas to be tried out every week so that like maybe we can find a few good ideas. So I think like I'm a little bit torn on that because I think what we're going to have in the medium term is we're going to do a lot of work to try to productionize the simple use cases, but then we're also going to do some amount of work to enable the truly custom work at the sort of leading edge of this goofiness. But those people are kind of on their own. They're like, they got to figure all this stuff out. And we see that now, like I think Google's TPUs are a good example of that, where they're really hard for most people to program. Like a lot of people outside of Google are like, what are these for? This is really a goofy API. I don't understand. And we're like, they're for super, super cheap. That's what they're for. Like they're for crazy cheap and crazy fast. Right. And like, just figure out the API. It's worth it. But that only works, if you have a big problem and you're well staffed.
Yeah, it seems like there's one of the biggest problems is going to be as an organization figuring out what are those problems that you guys want to really solidify, and other ones to kind of, we're going to put some stakes in the ground so that everybody can still be useful with it, but give them enough flexibility to kind of play around until collectively we all figure out like, yes, this is the direction that we want. Let's harden this sort of thing, and not doing it too early like you were talking about.
Yeah, I think that's a great observation. I think like I've mentioned this before, but I think a lot of these are product questions. They're not engineering questions. They're not SRE questions. They're not ML questions. They're product questions. Like somebody, and again, like in the engineering community, product managers get a bad rap, but a good product manager should be out there talking to a lot of users, thinking carefully about what they're trying to accomplish, and like coming back and saying, hey, this subset, exactly as you say, like this subset of use cases, all of these people had. And if you did all of this, it's not that much, but you'd be able to meet the needs of all of these people. Meanwhile, if you did this other stuff, you would be able to provide basic infrastructure that's customizable to those big users over there. And together, that might be the bulk of your sort of addressable market. I think that's right.
Yeah. And I want to take a step back, and you kind of briefly covered it. And you had mentioned something about for someone to just try out a model and to get it out and to see like, okay, what are the kind of results we're going to get? To me, that sounds a little bit like, and maybe I'm wrong, correct me if I'm wrong, is like model delivery. Is that a fairly solved problem at this point? Like in terms of treating model delivery as like a deployment of I'm shipping a binary, a verified binary out to multiple instances. And I just need to make sure like it's doing well and have all the rollback mechanisms. Like, is it pretty similar in that regards?
I do. I think that part is similar. I think it's the step that comes right before that I think is way, way harder. So if you already have a model in like some agreed upon format by your organization, we use safe model format or something like that, but like, some distilled format of the model that can be used by a server, then you just like ship it out and like you're done, So I think that's a solved problem. To me, what happens is before that, what happens when you have an idea for a model, right? So you and I work on the same team. You already built a model that solves some problem. Maybe it's a search ranking problem, and I have a better idea. I think I do. It turns out it's not a better idea, but I think I have a better idea. I'm like, I'm going to take Austin's model and I'm going to fix this up. I'm rubbing my hands together. I'm excited. What do I need to do that quickly? Well, I need all of the data that you use to train your model to be in a common feature store of some kind. I need metadata about all of that data so that I can know like, well, what were those feature columns or what were those data items and how did you use them? I need a snapshot of your model ideally so I don't have to start from scratch because I'm going to use transfer learning to steal straight from what you got. I'm going to strip out a couple layers and train my own layers on top of that or whatever, right? I am going to look at your model configuration to see how you built the model. And then I want to tweak that. And then I want to train a new model. And then I need a system to compare the two once I ship them. So I need like some system that does fractional traffic to me and to you, or like replays logs to me and compares it to you. that's actually a lot of moving parts, right? Like that's a lot of moving parts. But if I have all those moving parts, and if you have those for every team at your company that deals with data and is trying to solve these kinds of problems, that could be amazing, right? Like, because that's really what I'm talking about when I talk about unblocking innovation, is this dream of like, a new software engineer on a team, on some product team. They're like, a search ranking team, or they're, a message delivery team, or they're whatever, like they're Clubhouse. I don't know. They're like some team that's building some feature or something. You want that person to have access to data, other models, configurations, and an easy environment to tweak them and try again. So, but I do think if part of what your question was like, is this pretty similar to general binary delivery? Yeah, like a machine learning model is code. Absolutely. And thinking about it as code is the right way to think about it, which is also, by the way, why if you freeze code during like particular periods or holidays, you should definitely freeze model development as well, or model deployment.
Right,
yeah.
Right. Treating them as the same.
Yeah.
And again, taking a step back, you had mentioned something about like using similar features so that we have kind of a common base to come from. And this is maybe something common probably very common in the machine learning systems, which maybe differs from a lot of more traditional software engineering, is the need for feature engineering, both in the online for real-time space, as well as in the offline batch stuff. So maybe for our audience that's maybe not as familiar with the machine learning, that aspect, can you tell us a little bit more about feature engineering and what sort of complexities it kind of introduces?
Yeah, so I think like at its most basic form, I think of feature engineering as deciding what matters and putting it into a form so that you can use that. And like, that sounds like, wait, okay, did you actually say something? But so if you imagine, like, let's say we're trying to predict the temperature. Like, we're trying to predict the temperature tomorrow. Well, you know what? Knowing the temperature today, if we don't know anything else, knowing the temperature today, pretty good predictor of tomorrow. Like, it's unlikely to be 100 degrees Celsius different tomorrow. It is possible, but unlikely, right? So we can imagine like the feature that we would use to predict the temperature tomorrow is the temperature today. And they're like, that's not very good. What else? And so now you start to think like, well, actually a historical record of features going back quite a ways would help, because then like, okay, but what else? And you're like, well, the date that the temperature was recorded would be really useful, because it's possible that, a middle of April temperature is similar to another middle of April temperature. And then we start thinking, well, what else might be relevant? Like, well, what about the lat long, right? The lat long might be really, because if we know the location of that temperature. And so all of that work is sort of the initial creative side of feature engineering. But then comes the question of like, well, how are you going to store that? And what are you going to do with it? And then how are you going to combine those things into a model? Now, I will say one thing, that last step, I'm pretty sure the computers are going to do it better than us very soon. And in some cases, they already do. So I think like a lot of the AutoML technologies are better than humans at figuring out how to take a big bundle of features and turn them into a model that works. So that may disappoint people who are planning to build their careers on building ML models. But the people who are good at building ML models and are 5 years ahead of you are destroying your jobs right now. Like they're gonna, like, it's sad to say that happens sometimes. But if you understand how this stuff works, there's still plenty of stuff to do. It just won't be the manual, tedious task of let me try this one, let me try this one. But I think that as an SRE, one of the things that happens is during the process of feature engineering, we make some choices about how to distill and how to store data. And those choices actually have profound consequences on reliability. So I'll give a concrete example of quantization. Quantization sounds like a fancy word. It's actually off-putting to people who don't know what it is, but it's literally just like taking a numerical space like all of the integers and putting it in buckets. So you're like, well, and you can imagine this with age. You're like, I've got age. Everybody has a year of age. You're like, what if I only have like 12 or 13? How old's the oldest human? Not more than 130, right? So what if I only have 13 buckets and your age is just a decade? That's all. I don't store more. You might say like, well, why do you do that? And you're like, actually, I do that because I might not lose very much information, but it's crazy cheap to store. So you take a bigger space and you store it in a smaller space. Now, if you change the meaning of that quantization at any point in your system, you have just like not only thrown away data, you've ruined everything. Everything has gone to heck. It's all terrible, right? So like, for example, if you have one part of your system that quantizes age on decade and a different part that quantizes it on 5 years and a different part that quantizes it on 25 years, the age that you put in at the beginning is not apparent. There is no, if anything actually works in that model, it's pure luck, right? Like that's not, it was because age didn't matter because you just threw away all the useful information about age. But that's the kind of thing as an SRE is hard to see. And I think that for me in ML SRE is what's interesting is that's a good example of you don't have to know how machine learning works. You don't have to be tremendously sophisticated about it, but you need to know what quantization is and how you define it and where it's defined and ensure that those definitions are consistent. And similar with all kinds of other things, like it can be as simple as like you have numbered features and like the age was feature number 1. And then in serving, the temperature is feature number 1. Well, that's going to be a weird, like, that's not going to work well for you, right? And so, like, those kinds of very, very simple off by 1 errors or very, very simple configuration errors in traditional software services, they show up as like fatal errors or really obvious errors. You're like the web page didn't serve or, the contents of the table are empty. But in ML, it comes as people aren't so happy, or the results are kind of weird, but only for queries from China and Germany. And you're like, what's up with that? And you're like, that's just what's happening right now. And that can be the result of something more subtle in the data layer. And so that's what I think is exciting and frustrating about ML reliability.
That's really cool. So one of our questions was around that. So like monitoring, debugging. I've heard that one of the top reasons why engineers don't want to ever leave Google is because the tooling, is just so world class. So what kind of fancy debugging tools do you guys have for like, ML systems where, like kind of tackling like exactly some of the issues that you just pointed out?
Yeah. Well, so on your first point, I will say like that is hilarious because there is not an SRE at Google who does not complain incessantly about the terrible quality of our tools. They're awful. Like, so it's just funny, it is like, they are good, but like they could always be better and they're not good enough. I think so. One of the trickiest and most interesting things about model quality monitoring is there currently are no crazy general good use, good tools for like. There's no notion of like this model is good, right? Because it depends on what it's supposed to do. And so I think when I look at, so frankly, like I am dissatisfied with the state of general purpose infrastructure for this. What I think you can do, which is useful, is you can have a set of infrastructure that takes metrics and like lets users define metrics for their models that they'd like to track and can set some thresholds on those. You can also have infrastructure that runs golden sets through a candidate model. So in the case where people are building new models, this idea of a golden set is like, here's some questions and the defined correct answers, right? And so like, if you give me those questions and you give me a new model, I'll give you back the results and we can compare them to what you said they would be. And if the problem with ML is if they're a little bit different, that actually might be good because you might have improved the model. If they're a lot different, then we're not going to ship that into serving until we understand why it's a lot different. And so there's a couple things you can do at the infrastructure layer to facilitate that. But in all of these cases, you might have noticed, we're actually punting to the original model team to tell us what it's supposed to do. And what it's supposed to do is about is this a photo categorization thing? Is this a text prediction thing? Is this a fraud detection thing? Like until you know what the model is supposed to do, it's very difficult to tell whether you have a good model or a bad model. So I think we have some tools, but not enough yet, not even close to enough.
It's kind of interesting, the sort of, would it be fair to kind of compare to like test-driven development and then, moving that to like the ML side where at least you should know, or you need to be able to quantify, what your model does. And that becomes really difficult, right? Like kind of to your point, I feel like what I'm used to is having, like a golden set that's like very just specific at the record level. And then maybe you look some like general, like, maybe flag rate for your predictions or, if you're doing something else, but just very high level statistics. Is that also generally how you guys like? Is there like one thing that you mentioned? I thought that was really cool. Is like to do these like slices on like different populations, but that does feel like you would require quite a bit a bit of infrastructure to kind of enable those use cases.
Yeah, I think that's right. I think that like, so yes, like in general, you're like, we're going to have some like, so when you build a model, you have something you're trying to accomplish, some objective function. And so you train the model according to that objective function. And the objective function includes the things you're trying to accomplish. This model is trying to increase the quality of click prediction. This model is trying to increase the like satisfaction of users in this particular case. This model is trying to lose as little money as possible if it's a trading model or whatever, right? So you already have the general objective, the metric that you have, and you can track the model against that. But the problem is that these things live and breathe and the world changes around them and our understanding of the model grows. And so, frequently you're like, this is a great model, but not for this class of cases. Like this is a stellar model, but not for this class of users. So what do we do about that? Okay, well, I guess now, and that's really where the idea of these slices come from, is you start to really subdivide and say like, actually, like to meet the widest possible set of needs, I need to actually narrow my focus and then jump around, right? So like if you look at a text prediction, like the text prediction models were really, really good in US English and terrible in everything else. Okay. And then they added more languages and they got a little bit better. But until very recently, I think until last year, if you had 2 languages enabled on your Android phone, they were terrible because they couldn't figure out what language you were speaking. And so like, I don't know, I give up. I'm just saying stuff in the like, and half the time, like my phone is set to English and Spanish. And I'm like, this is just gibberish. If I talk to one part of my family, it's gibberish. If I talk to the other part of my family, it's equally useless. And that was like a case where if you think about that from an aggregate data point of view, how many people who have Android phones in the world have those 2 languages turned on? Most people don't even know you can turn on 2 languages. So I'm assuming it's like me and 6 people and like all 6 of us were getting bad results, but that washes away in the metrics. And so I think right now we still have to go back to the people who really understand the uses of the model and the people who really understand what the model is trying to accomplish to be able to start to get some infrastructure to look at slices. But I think like one of the things that, you sort of implicitly point out is if your model is important enough, it's important to spend some time understanding how well it's doing. And I can tell you, like, for example, for some of the ads models, we have, 15 years of analytics infrastructure to try to understand how well is it performing with these kinds of queries. How well is it performing in these markets? How well, and that makes sense, right? This is like a lot of money for Google. Google takes it seriously. We like want to make the money and serve the users' needs and like sell good ads. And so, but then in other cases, if it's just a little bit experimental, it's harder to justify that kind of analytical investment.
Yeah. And I think it's also even more interesting / complicated because like, during model development, there's also sort of evaluation and test, right? So then it's like, how do you build the infrastructure such that you bring that test as close to the actual like, production slices that you create? I feel like that's also a pretty big challenge, right?
I think it is. And I think like going back to the first part of your last question, I really think that thinking of the machine learning cycle, the pipeline of development as being very similar to CI/CD and very similar to just software engineering in general, like I think we should be moving in that direction. Well, to move in that direction, we need to think carefully about what's the general purpose testing infrastructure. Right. And when you think about it for software, like, this is maybe your point, like for software, like I also don't know what any given method is going to do. Like I require the user, like if you just wrote a function, you better tell me give me some unit tests. So I'll run the unit test, but I don't know what inputs the function. I mean, I can look at the header, but I don't know what it's supposed to do, but you do, right? And so I think with ML as well, we need to move towards, and there's a couple of pieces of open source that are starting to hinge on this, but I think infrastructure for model quality measurement and model quality improvement is something that we're going to see a lot of in the next few years. Because I think, like if I'm developing a model, the first thing I want to know is it garbage? And if it's garbage, but it's kind of garbage, what can you tell me about that? Like, how am I doing? Like, because that's how we're going to get better.
Yep.
Yeah, this sounds like shifting all the testing towards the left as we talk about general software. Thinking about the general pipeline for ML models, and like you said, we should also be thinking about this as like the CI/CD pipelines we have for non-ML systems. So like if anyone who has read the Google SRE book or just thought about productionizing a service, one normally thinks about, okay, I have kind of a production readiness checklist that I would go through and say, does it hit all of these things? Does it have a disaster recovery plan? Do I have my metrics, monitoring, alerting, and all of those things? I assume they would look a little different for a machine learning system, where like I have to care about the data distribution, like some of the problems you specified, like, hey, is your quantization configuration right throughout the pipeline? Did we miss data over the last month from a region or things like that? So when you're thinking about productionizing a machine learning model or a machine learning system itself with some of the complicated pipelines, what kind of quote unquote readiness checklist one would think about, or you guys think about?
Yeah, it's a really important question. I think the biggest challenge we have in even getting that conversation started is many model developers think they're going to develop a model once or a very small number of times, right? And so they really approach this with, I don't want to, just let me slap some stuff together, it'll be fine, which, right? So this is pretty common. And I'm like, far be it from me to get in your way, but like what's going to happen is 9 months from now, I'm going to be dealing with the crap you just slapped together, and like, that's going to make me sad. So I think like the approach, I don't want to slow people down. And I actually do think a lot of people do slap something together and discover it's not a good idea, or discover like they got what they needed to out of it. And they may update it once or twice, but they're not going to run it continuously, or they're not going to do 20 variations of it. But other people don't. And it's those cases where they don't that we really want to sort of intervene. I think the right answer here is we need to make the platforms do most of this, which puts pressure on do we really understand the use cases and how many of them can we accomplish? Because if the platforms do most of this, like the most common problem that we have on machine learning that's not sort of well structured is the data you wanted to use is not available, or a different version of it is available, or it's in a different format, right? That's one of the most common things that people are just like, I'm training a model. I trained this model before. I'm training it now. It's not working. You're like, why is it not working? Like, well, because 3 of the 26 data sources don't exist anymore, or are different than they were when you trained this model, right? And for many of the libraries that people use or training environments people use, that's actually hard for them to figure out. I think for us, the next most common problem that we really need to solve is just scheduling of training jobs. So like a lot of the machine learning training that people do at Google are very large, just because we have a lot of data. So frequently people say, I would like to train on all the X. You're like, okay, that's this many exabytes. How you feeling about that? And they're like, and half the time they're like, oh, that sounds fine. And they're like, okay, we're going to town. We're training on exabytes. And half the time they're like, what's an exabyte? Like, right, no, it's just fine. Like that means like that was not the conversation you thought we were going to have. So let's go back and try to figure out what you're trying to accomplish and if there's any other way to do it. Like, because frequently people just say like, I want all the X. And I'm like, do you want all of it?
Probably
like,
not.
Yes, all of it. No, it turns out probably not. But I think what we really need to do is start focusing on building those platforms so that by default, people get roughly the right stuff. And I think there's a tension there. Like I work with SREs, you all, work with or are SREs. Like SREs want to do everything perfectly. Actually, for the people messing around, I want to do something good enough. Like I really want to make it super easy to do first, and then have a reasonable path to super well done. Because I think super easy to do is how we're going to get people in the door. And so one of the things I've been thinking about recently is really thinking about these platforms in tiers that have different SLOs. And different sort of models of what quality works like. So I'll give an example. Like if you're just playing around with a model, you want to be in the serving system tier that syncs it out somewhere immediately, but you don't care if it's reliable. You just want to look some stuff up, right? And so you don't need it globally replicated with very high capacity allocated. You need to look up something in it right now. On the other hand, if you're syncing the 3,476th version of your model, and this is a daily update or an hourly update, if I take 20 minutes to get it everywhere in the world, you just don't care, but you do care if I drop any requests. You're like, I want it reliable. I want it fast. I don't care how fast the new thing is available. It doesn't have to be perfectly fresh. Well, as you all can know, if you intuit that, those are actually two different systems. They're related to each other, but they're fundamentally different requirements. And so I'm sort of arguing that for the people messing around, experimenting, trying to innovate something, we need to think about their needs as a first-class set of requirements that are different from the needs of the smaller number of very highly demanding production users.
This might come across as weird, but as you were talking about different requirements, in my head I was thinking about different databases, as there is not one database that fits all use cases.
Absolutely. Totally agree.
There's a relational store, there's a key value store, there's a document store, and you cannot just fit everything in one place because, well, requirements are different. In terms of thinking about these requirements, and also one aspect that you mentioned is, well, I want to know when it doesn't go right and when you actually put something in production. What does a feedback loop look like for both the SREs working on ML side of the world and also the model developers?
I think the interface between those two is the single most complicated part of ML SRE, and it's something we're still working on because, to be fair, I think that's actually complicated for a lot of services. Like many of our services are tricky and they're subtle. And so like a lot of us who have worked as SREs and who have worked as, application and platform developers, we argue about this barrier a lot, right? We're like, is this your fault or my fault? Is this like, and not fault, I don't want to be blamey, but I like, who should have the fundamental responsibility for fixing this kind of a thing? And so I think like my first step is like, let's be as collaborative as possible. But the very next step is going to be that we can't scale this SRE team if they're responsible for model quality issues. Okay. So that sounds good. We're like, model quality is the model owner. Sounds good, right? Well, the platform can mess up model quality. Right? We know that. So wait a second, right? So it sounded good. We're like, we're going to run the platform and you're going to run the models and the platform will take care of the models. But if the models are no good, that's your problem. Unless too many of the models are no good in kind of the same way, in which case that's our problem, right? So this is where it gets really tricky and really interesting. And honestly, like, I could spend a very long time, like I spend a lot of my day thinking about this and talking to people about this. But the short version is like, we haven't solved that yet either. And I think like anyone who's serious about making, multi-party ML platforms, unless I'm just stupid, like I think that's the meat of the whole thing. Like, it's weird for the vegetarian to be like, that's the meat, but like, that's the, that's the center of the whole thing. That's the value right there, is if you can figure that out in a scalable way so that model owners and model builders, they're enabled, everything's working well, they're excited about that, and they can fix their own problems when their models are bad. But the platform owners are kept out of that most of the time, but not when it's legitimately their responsibility because it comes from the platform. That would be the holy grail. That is not yet achieved in any of my teams, but we're thinking hard about it and continuing to work on it.
That's like a really good way of actually kind of capturing some of the, I feel like, my grinds with the problem as well. Awesome. So to wrap up, thank you so much for taking the time today, Todd. Just kind of the fun question that we like to ask. What was the tool that you recently discovered and really liked?
Recently discovered and really liked. So it's not software at all. Like I've been, so I live in Pennsylvania. So I grew up in Puerto Rico, where you can just like the process for growing things is you look outside and stuff is growing and then you eat some of it. And here in Pennsylvania, growing is intentional. And so one of the things I've been super excited about is like raised beds in the garden. They're freaking fantastic. I'm growing stuff. You can grow stuff and eat stuff. It's easier to get to. You can grow more of it because it's all loose. That's old school technology, right? It's just like boards in a shape with some dirt in them, but that's a thing. I know that wasn't what you were expecting, but I'm talking raised gardening beds here, buddy.
Showing off that you have a yard and a garden. I see you, Todd.
Come to Pittsburgh. Houses here are cheapest chips. You can buy several of them. The number of my like middle career engineering colleagues who like just keep a house when they move because they might need it later. Like the houses are cheap here. You should come move here. It's great.
Must be
talking
nice.
About gardening, like it kind of reminded me of your LinkedIn skills section. So I did more stalking on LinkedIn.
Yeah.
I want to call out a couple of things, and I think anyone who hasn't looked at your LinkedIn profile should just go and look at the profile because it's very entertaining, to say the least.
What do I got? What are you seeing?
One of the things that has... Okay, so there are things like terracotta, retaining walls.
Terracotta, right? Like, I don't know. I don't actually know that much about terracotta, but I just love these skills that are a noun. Like, why is there a skill that's a noun?
So there are two which are also very interesting. Third world driving.
Absolutely.
+1.
I relate. It's different, right? Like, so when I drive in the Caribbean or I drive, like, you just drive differently. This whole idea, like, Americans are like, every lane is sacred and you're supposed to stay in it. And if you try to stay in your exact lane in a lot of parts of the world, that's not going to go well for you or anyone else. You need to have a much more flexible, aggressive notion of driving. Yeah.
So someone told me it's like the water is flowing and you need to be part of the water in the traffic.
Just join the water, be part of the water. And I don't know if you heard this, there was a good Freakonomics episode on roundabouts. And one of the things that came out of that is roundabouts are one of the hardest problems for self-driving cars because, like, if you actually do it right, you should definitely never enter a busy roundabout. There's no safe time to enter a roundabout. And so they're like, well, you got to kind of guess and try, but also be ready to stop. And like, it's really, apparently really hard. What was the second skill?
So the second skill was political asylum. I'm like, that's interesting.
Yes. I don't know. So the where this came from, the way I found out about this is a coworker, Andrew Eames, endorsed me for nuclear proliferation. Not anti-proliferation, which I also don't know much about, but for nuclear proliferation. And like, it came to me as a notice, like, do you approve this? So I'm like, first of all, yes. But second of all, how did you do that? And that was where like the whole thing got started. So
I see. So the last one I'll say, and it seems that you are really good at this skill because you have the most endorsement on that one. And it's getting LinkedIn skills endorsements. And you have
that's what I'm telling you. That is a self-documenting skill. Either a lot of people endorse you for it or they don't, in which case it is what it is, right?
Oh, yep, absolutely.
Feel free to like peer me on LinkedIn and endorse me for getting LinkedIn skills endorsements.
Oh, for sure. I'm going to +1 to a lot of these because,
good.
We have the proof now.
Proof. Excellent.
Well, moving on. Is there anything else you would like to share with our listeners, Todd?
No, this has been a great conversation. I think like the kinds of topics that you all are raising here are like of super general use. Like this is, I think a lot of people get focused on ML, AI. There are subtle things about what we're doing that are a little bit different, but there are a lot of things that are just about modern distributed computing and how software works on like medium-sized collections of computers. And a lot of people work on software on medium-sized collections of computers. So I think the thing I would say is, for people who are going into ML and going into data sciences, if you're excited about the model building and you're excited about like that side of it, you should go to that. But there's going to be a huge amount of work for a very long time in making this stuff work. And so if you are a software engineer, you are a systems engineer, you are a data like management engineer, and you are an SRE, like this is really, really good stuff to know. And you should not be worried about not having the academic background in modeling.
Oh, that's really good advice. On that note, thank you so much for taking the time, Todd. This has been awesome.
Yeah, it was great. Thanks for having me.
Hey, thank you so much for listening to the show. You can subscribe wherever you get your podcasts and learn more about us at softwaremisadventures.com. You can also write to us at hello@softwaremisadventures.com. We would love to hear from you. Until next time, take care.